Hi, welcome to the pre-calculus lecture series. And we are in this video, we are continuous working on the chapter 3 practice test. Our previous video, we finished the first 4 problems on the chapter 3 practice test. And for this video, we're going to work on the last 4 here. Okay, so now let's go ahead to our practice test worksheets here. Okay, so this is the problem number 5 here. All right, so let's start. Okay, so we have 2 rational functions. And so first things here, let's take a look to see if we be able to factor. So here, this one's x minus 2. Well, I think we can factor here, right? This is x minus 4, x plus 4, okay? Okay, so now let's take a look. What is the x-intercept? X-intercept is y equal to 0, right? So x-intercept is y equal to 0. That means this is my y's, right? That means this is x minus 2, x minus 4, x plus 4, plus 2 equal to 0. So we know a fraction equal to 0. Which part can equal to 0? Only the numerator part, correct? Okay, so that means what is here? X equal to what? X equal to 2. Okay, so my x-intercept is 2 and 0. Okay, so now the part B, what is the y-intercept? Y-intercept is x equal to 0, right? So that means you substitute the x with 0, so it's 0 minus 2, so it's 0 square minus 0 minus 8. So what is here is negative 2 over negative 8. So what do we have here? So it's 1/4, right? So the y-intercept is 0 and 1/4. Okay, so now the part C. So this problem is a pretty good summary about all the key points we need to know about the, the key things we need to know about the rational functions here. So vertical asymptote. So what is the vertical asymptote? Okay, so vertical asymptote is what? It's the denominator be equal to 0, right? So that means x minus 4 equal to 0. So what is here is x equal to 4, and the x plus 2 equal to 0, and what is here? X equal to negative 2. So the vertical asymptotes here, we have x equal to 4 and the x equal to the negative 2. Okay, so horizontal asymptotes here. Okay, so the horizontal asymptote, that means you compare the degrees of the 2 polynomials on the numerator and the denominator. So this is x minus 2, so it's really x power. And so it's here, so this is the first power, this is the second powers, right? All right, so that means, the denominator's degrees is higher, so what is the approach to? Approach to zeros, right? So I know the horizontal asymptote will be 0, so that means it's y equal to 0. So we say this is y equal to 0 here. Okay, so now part E is here. We said, do we have any slant asymptote? So the slant asymptote only exists if the degrees of the numerator is bigger than the degrees of the denominator. So the numerator degrees is 1, denominator degrees is 2. So do we have any slant asymptote? We say no, we don't have any slant asymptotes. Right, because the numerator is the first degree and the denominator is the second degree. So that's why it does not exist. Okay, so we don't have a slant asymptote. Okay, so the domains here. So we know the domains here, right? So the domain is everything except the denominator equal to 0. So we say it's all the x in the real number, and but the x cannot be equal to what? 4 and negative 2 here. Okay. And then the part G here, they said, hey, do we have, what is the range you see here? So the range is y values here, right? So the y value can be anything except, so domains here, let's write here. So this is x, the x belong to the real number, but the x cannot be equal to 4, and the x cannot be equal to -2. So the range is the y value. So for here, this is the y values here, right? So the y value can be, so it can go to the infinity, to -infinity. But in here, because I have a horizontal asymptote y equal to 0, that means in this graph, when you graph it, it's probably going to, graph is something like here, so if you graph it and you can see, and then something like here, something like that, right? And in here, okay, so we need to be, so let's see here, because because here the vertical asymptote, they're going to touch the 4 here, right? So the x equal to 4 touch the 4. And the horizontal asymptotes here, these two legs, they're not going to touch y-axis. But in here, because they go through the, they go through the, the x-axis, the x-intercept, right? And so that's why, the x-intercept is 2 zeros here. So they do go through the x-intercept, it's 2 zeros. So y is equal to 0 exists in here. So the range is here, the y is a whole real number. So be careful, right? If they don't have the x-intercept, then because of here, right? Because of horizontal asymptote y equal to 0, so then the range you need to exclude 0. But in here, because of the x-intercept, then I know y is belong to the whole real number. Okay, so what is the wholes here? The wholes, we say, is if you can have a common factor, you can cancel that out. But if you take a look here for our problem, do we have any common factor? No, we don't have a common factor. So whole, do we have any wholes? Not exist, right? So we don't have any wholes. So it's not exist. It's good. Okay, so now let's take a look at the next ones here, all right? So the next one's here. This one still, every time we see the rational, let's take a look. We'll be able to kind of let's factor it. So this one could be 2 and x minus 7, right? So this is, okay, so no, this is plus. So this is a plus 7, all right? So this is a plus 7, and this is a minus 2. All right, got it, right? So this is a minus 2, and this is a minus 2 here. Oh boy, right? Okay, so now you see these two can cancel here. So if they have the common vector, right? So immediately I know what is that? That is the wholes, right? So I have a whole at x equal to 2. Because this is the common factor, I can cancel that. That means that at x equal to 2, I have a wholes here. And then after you kind of cancel these ones here, so the whole thing will become x plus 7, right? Okay. Okay, so now let's take a look at y-intercept, x-intercept, right? So x-intercept is y equal to 0, right? So that means, let's see here. Okay, so here, let's see A, x-intercept. That means y equal to 0. So it means x plus 7 equal to 0. So what is x here? X equal to -7. Okay, so this is -7. And the y-intercept, what is the y-intercept here? Y-intercept is x equal to 0, right? Okay, so I have a y-intercept here. I need to write this is 7, 0. So y-intercept is x equal to 0. So y equal to what? Y equal to 7. So I will say this is 0, 7. Do I have any vertical asymptote? No, right? Because my 1, the negative denominator, let's cancel out. So we say no, we don't have, not exist. Okay, so do we have any horizontal asymptote? Because horizontal here, this is true, this is 1, it's greater than. So the horizontal asymptote is not exist neither. Do we have any slant asymptote? Yes, do we have any? Or no, here, right? So it's no because this one is canceled. Don't just look like it says, hey, yes, because this is greater than that. Yes, in general, it's true. If this is greater than this one, I have a slant asymptote. But these ones here, they cancel out, right? So this is the holes got to cancel out. So the slant asymptote does not exist. Okay. And now the next thing here is, do I have, what is the domains here, right? Domains is like everything, but I have holes here. Holes means that's not, you cannot have that. So that's why it's my domains here. I say it's x belong to what? Real number, but x cannot equal to what? Equal to 2 here. Okay, so now let's take a look. The ranges here, right? So for the ranges here, and so like in here, okay, so like in here, I know that my graph going to look like something like this, right? Okay, right? It's lines, right? So y equal to the x plus 7. And here is like 7, here's a negative 7, right? Because that's the x-intercept and the y-intercept. Now let's take a look at the ranges here. I know at 2 here, be careful here, right? So at x equal to 2, I have a hole. That means in here, I have a hole here. Okay, so what is these holes here? So if you plug the 2 into the equation, so this will be what? 2 plus 7 is 9. That means I have holes here at 9. Do you get that? Right? So the hole at 9, that means y can be any number except at a hole. So I said the range is y. So y is belong to the real number, but y will not be equal to what? Will not be equal to 9 here. Okay, so be very careful when they have holes here. That's what you need to do. Be very careful here, right? Okay, so now let's take a look at how to solve the inequalities. Okay, so we said to solve the inequality, we have a few steps, right? So first step, moving everything to the one side. So you have a 2x squared minus x minus 3 greater than equal to 0 here. Now, what is the second step? Factors, right? So factor here, so I have a 2x. Okay, so this one should be minus 3 and x plus 1. Let's see, is correct or not? Is 1, 1, 2. Yeah, okay. So now we set this one equal to 0, this one equal to 0, right? Okay, so this one equal to 0, this one equal to 0. So what I have x equal to the 3/2 and x equal to negative 1. Okay, so after that, then like in the video, we say we do a little tables here, right? Okay, so in here, we arrange it. So this is a negative 1. So we put the negative 1s here. This is 3/2, right? Okay, and then this is my put your 2 terms here. That is x plus 1. Okay, then you go over all these 3 intervals here. So choose anything less than negative 1. That's the negative 2. So what is here will be a negative. Like negative 2, what is here is negative, right? Choose something in between. So what is in between here? Let's choose 0. So it will be negative. Okay, so this will be positive, right? So this is a negative. So this is a negative. And if you choose something here, this is a positive, right? And then if you choose something greater than that, choose 4. Okay, so if you choose 4, what is going to be here is a negative, and what? And the positive here, right? Okay, and now in here, now you kind of Combine that. Okay, so now you say here, this is negative, negative will give you what? Positive. Negative, positive will give you what? Will give you negative. Negative, negative will give you what? Will give you negatives here. Right? Did we do that correct? Oh, no, here. Okay, so this is the, okay, so they get rid of my lines there. I don't know why. So this is a positive, right? So this is a positive. And then you guys still remember what to do here from our lectures here. Now you look at your initial inequality. Your initial inequality is greater than or equal to 0. So if it is greater than equal to 0 here, so I choose the one with the, with the positive sign. And then because also this is equal, so I can write the solution. So this ones here will be negative infinity. So because this is a positive, so it's a negative 1. And the unions here, this is the equal sign, so it's a 3/2 to what? To the positive infinity, right? Okay, that's it. Okay, so now it's pretty easy, right? Okay, so now let's take a look. So like I said, solve the inequality, the hardest part is to try to factors here. Okay, so now this one, let's start the factors here. So this is x4 is x squared. Okay, that's not too bad. So this is x4, x squared, right? So what I can do is I can do like this, kind of like treat this is x squared and x squared, okay? So now it's 18 and 7. I know it's 9 and 18 and 7. So it's 9 and what? 9 and 18 and 7. Okay, so it's 9 and what? 9 and 2s, right? So here, 9 and 2. So I need to have here, I need to have what? This will be positives, right? Did I get that one right? All right, so that's right. So it's an x4, so 9x. Okay, so now continue. I saw here, this is, remember in the chapter 1, we said this is such an important factor, right? It's a squared minus b squares, right? So we will have, this is x squared plus 2. Then this is x minus 3, x plus 3. Then we set equal to 0. We set all this equal to 0 and find the solution. So I say, hey, this one's here, x equal to 3. And what is this one's here? This is x equal to the negative 3. And here, x squared, always greater than 0. No such value will make it x squared plus 2 equal to 0. So I only have 2 points, negative 3 and 3. Okay, so let's do the same things here, right? Okay, so to do the same thing, let's put here, the first number is negative 3, so it's here. Right, negative 3, so it's here, right? Okay, now let's try to write that out, our terms, x squared plus 2. So this is x minus 3, this is x plus 3 here. Okay, so now let's take a look at the negative or positive. So for everything, so these terms is always positive, doesn't matter because it's x squared plus 4, so it's always positive. Okay, so choose anything less than negative 3, so negative 4, so this is negative. All right, choose anything negative, negative 4, this is negative. Okay, so here, choose something in between, so this is negative, this is a positive. Choose something bigger, so this is a positive, positive. Okay, good. All right, so after that, then let's summarize this. So this one here is negative, negative, positive. This is a positive. This is a positive, negative, positive is negative. And this is positive, right? Now take a look. What is my original one? It's less than. So which area? I'm looking for this areas, right? Okay, so I can write down my solution. Because it does not have the equal sign. So what is my solution? It's a negative 3 and 3. Okay, Okay, so pretty easy, right? Okay, so now number 7, how to solve the inequality for the, the rational functions here. So it's very similar like the polynomials, right? So what do we need to do here? We need to move everything to the left, to one side here. So I have 3x plus 1, x minus 2, minus 2/3 less than equal to 0. Okay, so what is the next thing? Hey, we need to find the common denominator and combine it, right? So this will be 3, this is x minus 2, minus 3, this is x minus 2, right? So this one's here, so you will just have 3 and 3x plus 1 minus 2, so here this is x, right? So the minus 2 is here, right? Less than equal to 0. Okay, now let's try to, so this is 3x minus 2. This is 9x, be careful. The distributive property, you need to carry all the name. Then the minus 2x, be careful, this minus sign need to be carried to both. So it's minus 2x plus 4, right? Okay, so it's less than equal to 0. Then here, this is 3x minus 2. So how many x here? So this is 7x. Okay, so this is a minus, right? So this is a minus minus. So how many here? I have what? I have 7, right? Okay, so this is less than equal to 0. Okay, so I have 3, 7, x minus 2, and this is x plus 1, right? So then after we do that, what do we do here? We set this one equal to 0 and this one equal to 0 and try to solve it. Okay, so you set all the factors in the numerator and the denominator equal to 0. So I get x equal to -1, x equal to 2. It's good? Okay. So did I look at the problem? Let me see here. The problem say this is x. Oh, here. Oh boy. Oh, I think I missed. Okay, okay. So here, this is x plus 2. Ah, my bad. So x plus 2. So this is x plus 2, right? So this is a plus 2. So minus minus. This one is negative. I like the previous one better. It's easier. So this is minus, right? So this is x plus 2. I need to be careful. So this is 7x here. Now the last term is not a plus 7. So what is that? It's a minus 1s here. Okay, that's not bad. Okay, so we still, okay, so this one's here. So this is a 7x minus 1. So this is x plus 2. All right, now we do the same things here. Okay, so we have both of the factor equal to 0. So what I have, x could be 1/7 or x equal to -2. Okay, just need to be careful. I thought it's x minus 2. It turns out to be x plus 2. Okay, so now let's do the same way. So we can put it into our little tables here. So the -2 is in here, 1/7 is here, right? Now let's put my factors here. Factor is 7x minus 1, and this is x plus 2. Okay, so for anything is less than, let's say here for anything is less than -2, like -3. Okay, so this is negative. This is negative. Okay, anything in between, let's say 0. So this is negative. This is a positive. Okay, anything greater than 1/3, say 1, 1/7, So this is a positive. This is positive. Okay, good job. And then we got it. Then we can finalize my negative, positive. So this negative become positive, negative, positive become negative, positive become positive. So let's go back to check to see what my original inequality is. Oh, here is original quadrant is less than or equal to 0. So here, so less than is here. Okay, so less than equal to 0 because they do have the equal signs here. So let's put it here. So this is -2 and the 1, 7. I know if they have the equal sign, I need to use a bracket, right? So 1, 7, I use bracket. But for the -2, can I use a bracket? No, I cannot use a bracket. Why? Because x plus 2 is in the denominator. If I use the bracket to include the -2, then the denominator will be equal to 0. So I need to use what? Parentheses here. All right. Okay, so now let's take a look at this problem here, right? Okay, so the same way here, let's try to move everything to the left-hand side. So this is a 2x minus 5. Hope this time I did not look at the problem wrong. So this is less than 0. Okay, common denominator. So this is a 2x minus 5 minus 2x minus 5. So if the x you put a common denominator, you need to times x is 2x minus 5. Then minus 6 minus x is less than or equal to 0, right? Okay, so combine the common denominators here. So this will be 2x squared minus 5x minus 6. Minus is what? It's plus x here. All right. This is less than or equal to 0. Okay, continue simplify. So this is 2x minus 5. So this one is a 2x squared minus 5x positive x is minus 4x minus 6 less than or equal to 0. Oh, I can factor something out. All right, so this is less than 0. I can factor 2 out. This is x squared minus 2x minus 3. Yeah, I can factor that one easily. So this will be x minus 3, x plus 1, right? And this is a 2x minus 5 less than or equal to 0. Okay, so now I have to factor everything, so I can set all these factor equal to 0. Okay, so x is going to be equal to what? X minus 3 equal to 0, x equal to 3, x plus 1 equal to 0, x equal to -1, 2x minus 5 equal to 0, x equal to the 5/2. Right? Okay, after that, and then we just do our little table and to decide where we go, right? Okay, so here, this is our little table. Make sure we got it on the orders here. So the smallest one go left. So this is -1. So what is the next one? So 5/2 here, right? So go here, then 3 go here. Right, so you need to always, that's the one thing here, also be careful, you need to arrange that. So what is my factor have? I have x minus 3, x plus 1, 2x minus 5. Okay, so now let's choose any number less than -1. So this is negative, -2. So here, -2, but this is negatives, right? Okay, anything between 0, so this is negative, positive, 0 is negative. All right. Okay. And then let's see here. This one, so like a 5, 2 to 3, so it's a 2.9. So this is negative. This is a positive. 2.9. So this is a positive. That's right. Okay. And now greater than 3. So this will be positive, positive, positive. Good. Well, good job here. Now, let's try to summarize my negative. Negative is negative. Negative, positive is positive. Negative, positive is negative. Positive is a positive. Now, let's take a look at original. What do we want? Hey, we want less than or equal to 0. So this will be the area, this will be the areas, right? And then because it's equal, we need to consider is the bracket. So here, this one is from -infinity to -1. So let's see, can we use a bracket? Oh yes, because it's on the denominator, doesn't matter. It's on the numerator, doesn't matter, okay? Then union here. Now the next ones here is from the 5/2 to 3. Okay, so 3, can I use a bracket? Yes, because in the numerator. But 5/2, I cannot, because that's the value, make the denominator equal to 0. So I need to use a parenthesis here. Okay, so now let's take a look at our last province here. This is the one. So let's say, let me get that. This is a little bigger, so graphic is easier to see. Okay, so now in here, see here, by using the transformations. Okay, so when we try to do that, the first things we need to be careful is, you know, if you have the same things here, right? So then you need to change that. So this is x minus 3. And this is, you can factor, this is x plus 3, okay? Okay, so now let's use the long division to see what we have here. Okay, so this one's here. So this is x minus 3, and this is a 2x plus 6, right? So this one you need to match, so you do the 1/2. So 1/2 times 2x is x. 1/2 times 6 is what? Is 3, right? And don't forget, the long division is what? Is minus. So -3, +3, so it's -6. Okay, so I can find this one will be 1/2 minus 6 to the what? To the 2x plus 6, right? Or you can simplify this as a little bit. It's minus, so it's 3. This is x plus 3, right? Okay, so now let's start, okay? Let's start, okay? So let's do the parent function first. The parent function 1, 1. Maybe I can do like, okay, so maybe I can make it it's a little bit bigger, so it will be easier to see. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Okay. Okay, so the parent function is 1/x, right? So it's 1/x. Half is 2, and 2 is a half. So remember, we do the dotted line. So this is our dotted lines here. So this is a -1. 1/2 is -2. 2 is -1/2. Okay, so good. Okay. Okay, so then the next transformation I'm working on is x plus 3. So what's that mean? That means I am moving what? I am moving to the left 3 units here, right? So this point is going to do 1, 2, 1, 2, 3. This point is going to move to here, and then this point is going to, okay, so this point is going to 1, 2, 3, going to move to here. This point is going to 1, 2, 3, going to move to here. And also, don't forget we said this is the vertical asymptote need to move 3 also. So 1, 2, 3. So this is my new asymptotes here. Okay, so now, so I move all this point here. So let me erase this one. So maybe you can see, so this one I already taken care. I moved everything to the left 3 already. Okay, so now this one will be my functions here after, right? So this is my function. And then the same things here. Okay, so now the same thing in this one's here, I need to move 3. So 1, 2, 3. So it's in here. And this one is 1, 2, 3. So here. and this one is 1, 2, 3 is in here. And this is still is my new vertical lines here. So now I can, okay, so let me erase the older one so we don't overcrowd my graph here. Okay, so here. Okay, so here, so this is my first transformations, right? So here you still go like this. Okay, and then the next things here I'm going to do is this flip, right? So I'm going to do this ones here. This is the negative signs here, right? So what does negative one mean? That means flip, right? Okay, so let me flip it, right? Okay, so I'm going to flip it. So here, this one flip over to here. This one flip over to here. This one flip over to here, right? So my graph right now is going to be like this. Then the same way, this one going to flip over to where? Flip it over to here. This one going to flip over to here. This one going to flip over to here. So this is my third transformations, right? Okay, so now let me erase my previous one so I don't overcrowd that one. Okay, so now we can have a cleaner the space to work. Okay. Okay. So now the last one, the other ones here is the one I'm going to do is this threes here. Oh boy, so it's go too much here, right? Okay, so the next things here I'm going to do is this one here, this 3. So what does that mean? That means times 3, right? Okay, so times 3 here. So let's go ahead and do that. So times 3 here. So that means these numbers here, this is ones, right? So times 3, so going to 1, 2, 3. So this one going to go up here. This is 2 times 3 going to go up to here. 1/2 times 3 is 3/2, so it's going to go up to here. Okay, so this will be my, right? So my asymptote still did not change, right? So this will be my go up like this, and this one is a continue go like this, right? Then the same ways here, this is -1 times 3 going to go down to here. This is going to go down to here. This one going to go down to here, right? So this one's here still you're going to go. So this is the, so this will be my another graph here. Okay, so now let me erase the green one so the you don't overcrowd it here, right? So here. Okay, so here, right? Okay, so the last one's here, right? So then the last one here. Okay, so let's see here. The last transformations here I have is plus, right? So it's a plus 1/2. What's that mean? That means I'm going to shift up 1/2, right? Okay, so let's take a look at shift up here. So that means I add up 1/2 here. So this one's here, 1/2 add up is here. Go up here is here. This one go up 1/2 is here. This one go up 1/2 is here. All right, so now this will be my final. Then this one's go up 1/2 is here. This one go up 1/2 is here. This one go up 1/2 is here, somewhere there, right? Okay, so here. Okay, so it's somewhere here. Okay, so now I can finally connect all this with my solid lines here. So that will be my transformation of this function. So it's pretty cool, right? So it's like, you know, we used 4 different transformations here. Okay, let's see it. All right, so this practice test is a good summary of all the key points of the polynomial and the rational functions. Okay, hope this help to help you to study for these two topics here. Okay, sounds good. And I guess you have a good day, and I talk to you later. Okay, bye-bye.